are you all? I hope so. Everyone is all right, fine. So, welcome back to your new channel, ICSE in one shot. In this channel, we prefer the one shot videos of all the videos related to that of physics, chemistry, biology, that is pure science in one shot for all the topics related to our further reduced syllabus. So today we're gonna keep our look onto a very important and the preliminary chapters of physics, which is force, and we are gonna do it in one shot. So don't worry about it. We're gonna finish everything in one shot. Okay, every topic we're gonna deal with it. Okay, so let's start. My name is Nijam Rizvi. I study in Don Bosco School, Berhampur. Now I will be letting you learn the new topic in one short glance. So let's begin. So what we're gonna do today? We're gonna do force in one shot. Okay. So let's begin with the topic. And I would like to say to all of you that my habit is to begin everything with a fresh quote. That is, sometimes you don't realize your own strength until you come face to face with your greatest weakness. Such a deep thought, no? Said by Susan Gale. All right. So, keeping that in mind, let's start the session. So, what we're gonna do is, first of all, we're gonna let me change the color ink. Wait. Okay. We're gonna cover up what is torque and couple. Then we're gonna look over at equilibrium and principle of moments. Then center of gravity, uniform circular motion, and finally we're gonna conclude the chapter with centripetal and centrifugal forces. All right. So let's begin. I'm too excited for the session. Yeah. So what's force? Let's understand the force. What is the force actually? See, force is a push or pull that causes motion in a body. Okay. So you're gonna see this boy. He's trying to, pull the gate, but actually he's gonna push it in order to open it. Now, what is a force? Force is gonna make two kinds of motion, as you can see it. Okay, it's either gonna wait, let me change the color of the ink. Okay, it's gonna either make linear motion or it's gonna make rotational motion. Now what about this? In this wheel, you're gonna see it's gonna rotate on this very body. Okay, so this is gonna undergo a rotational motion. All right, and this one, that is gonna roll on the motion of to and fro motion, because of the wheel is gonna undergo linear motion or translational motion. Okay, so let's move on with the topic. First of all, let us consider two metallic rods. Okay, one is completely free to move, all right, and the other one is fixed to one end. What happens when one is fixed to move? And then I'm gonna show you the next instance. See, in this case it's not, in this case, okay, in this case it's not fixed. Okay, so it's not fixed, and you're gonna apply a force over here, and you're gonna push the object towards a particular direction. So what's that? That's the translational motion. Okay, because it's translating, it's not stationary anymore. And what's this body gonna do? This body is fixed at one point and it's gonna undergo rotational motion. What is this called? What do we call this? Yeah, what do we call this? What is the name of this special name? The name for this is the pivoted end, right? Okay, so let's move forward with our topics. Very easy topics and quite interesting also. So we understood the two concepts when we apply forces on both ends of the wire. When keeping that, one end is fixed, that is pivoted, and one end is translating. So two kinds of motion, translation and rotational. Next, see here I have given it. In translational motion, the rod moves in a straight line path in the direction of force. Okay, so it's gonna move straight. Okay, and in case of rotational motion, the rod absolutely doesn't move, it's fixed to a specific point. Okay, so that's the thing. Next, see here the extended line. So now you get to understand one thing. See this force which acts here. This force is obviously acting in a particular direction. All right. So if it's acting in a particular direction, the plane or the extended line is called the line of force. Keep this term in mind. Okay, so we're gonna need it next forward in understanding few of the more concepts in the chapter deeply. Okay, now if the line of force is through the pivot, oh my god, if it's through the pivot, god help, can't do anything. Okay, so what happens is that you can't move it. Anyways, these two instances are very crucial, keep that in mind. Okay, if in exam it's asked that in which two instances does a body not move, you can write, if it's given to draw, then you can draw these two instances. If it's given to write, you would write that if the line of force passes through the pivot of the arrangement, the body is not supposed to move. That's the rule. Okay, so let's move forward. Next, now see, I've already written this. So what's happening mathematically? Let's see. Do you see one thing? We're getting into the definition of moment of torque, moment of force. Okay, then please don't mind my mistake which I said. It's torque. Okay, so what happens in torque is that it's force, your force you are applying on the body. This force, and this force has got a perpendicular distance. See, this one is the pivot, this one is the pivot. Okay, and from there you see a particular perpendicular distance. See, this is the line extending, and here you are applying the force like this. Okay, this is the perpendicular angle. Okay, this is the 90-degree angle. You need to understand that. That happens is that force into perpendicular distance. So we denote force with tau symbol. This is the tau. Okay, let me draw it to you. This is the tau symbol. Okay, so tau equals to force into displacement. Keep that in your mind. We're gonna need it further in the numericals. And we know the surname of torque is, do I need to say it? Yeah, it's obviously moment of force. All right. Okay, let's move forward. So now you see few of the instances are given. When the hinge, as I said you, if the line of force is extended through the pivot, body is not going to move, so no torque in this case. Then see, no torque. Okay, when there is perpendicular distance is maximum, this maximum, it's the most edge point. If you see your door, if you're applying exactly at the foremost corner of your hinge, the door is gonna open violently. You're gonna hear that rusty, nasty sound of the hinge of the door. Okay, but see if you are applying the force at the hinge, does it gonna move? Try it in your home, but be sure not to just you know keep put your hand in the hinge and someone then picks it. Oh god, it pains a lot. It pains a lot, dude. So let's see. Plenty of torque in this case, as I said you, maximum displacement. Half, so half as much torque to the maximum displacement, and here no torque since it's passing through the extended line or the line of force. Okay, let's move forward. Now I've defined the torque. What is torque? Torque is defined as the product of force and the perpendicular distance between the line of force and the pivoted end. Okay, so what's the SI unit? I'm gonna write the formula for all of you, which is, wait, I'm writing the formula. See, tau equals F into D. Okay, so what's the SI unit of force? Remembering Newton. Yeah, Newton. Newton is the unit. Okay, and distance meter. What's the SI unit of the moment of force, which is the torque? Newton meter. All right. So now when we are converting these respective units in their CGS ones, what we get is 1 Newton is 10 power 5 dyne, and 1 meter is 10 power 2 centimeters. Okay, so 1 Newton meter is nothing but 10 power 7 dyne centimeters. Remember this derivation. Okay, this you would surely get in your exam, that 1 Newton equals to 10 power 7 dyne centimeter. Please don't mind my handwriting. Okay, since this screen is a little small, so it I get a discrepancy in writing. Okay, so let's continue. So keep that in mind. Okay, see, one question I have made to you. Pause the video and just try to answer it. Okay, if you are understanding the topic well, then surely you're gonna rock in this question also. See, it's given a body is acted upon by two forces of equal magnitude F in the opposite direction. State the effect of the forces acting on the same line of force. Take your clock, put 30 seconds, pause the video and start answering. See, I'm gonna give you few of the questions like this only in the upcoming slides. Okay, so you're gonna do the same, pause the video and just try to solve by your own within 30 seconds. May it be statement or by numerical. Okay, the hard numerical, then take 1 minute. I hope your time is finished now, so let's go forward and see the answer. Surely that's all the above. You know why? Because see, it's said acting in the opposite direction. Okay, then it's written resultant force. Resultant force will be always zero, no? Two forces of equal magnitude, so resultant force is always zero. And moment of force, what we got to know, that's force into displacement, right? So here, if resultant force is only zero, then displacement, whatever might be the value, ultimately tau will come zero, no? There will be no motion. Obviously, if you think your instance only, you're having a burger in your hand. Okay, you have a what to say, younger sibling. You both are snatching the burger like anything, God's sake. Then what happens is that, is the burger gonna move if you both have equal strength? No, it's gonna tear apart from the center. Don't say that happened to me, right? Let's go forward. Next question. See, this one is a very good numerical. Pause the video and start doing it. I'm gonna give you more 30 seconds. Clock your watch. Pause it. Okay. I hope you paused it and let's go forward to the solution. See, I've already made the solution. Force is 125 Newton, okay? And tau, which is the moment of force, which is given to me as 25.75 Newton meters. So what we know, tau equals to F into D. So we can write here D is equals to tau upon F. So what that comes? That will come around 0.206 meters. So let's knock at the answer. See, the solution is all right. Marked. Congratulations to all those of you who got it absolutely correct. Let's go forward. Now, we're going to understand one more new topic, which is couple. Couple is what? Now, don't search in your Google what's the definition of couple and just, come here to my video and then comment it downwards that, sir, brother, you taught very wrong. Couple doesn't mean that, which I'm going to teach you after something. It's very wrong. It's not gonna mean that. It's gonna mean something else, which we are not supposed to discuss also. Let's go forward. So here you see, you have seen a steering wheel in your bikes, in your cars. Mind my mistake. I just thought of my bike. Okay. Nonetheless, here's the rotation is caused by two equal forces, okay, acting in the opposite direction to each other, okay. Now, when the thing is that when I am applying one force from this direction and the other force in this direction, okay, so I'm gonna get the motion. Absolutely, you put one of your hands here and one of your hands here. Yeah, like that you put this motion, right? So what happens is that two equal forces. This is not that this side you apply more force, this side you become Hercules, and this side you become like the lean man. It's not that. Not that, bro. You can't do it. Your body is mechanized yourself. So your two equal forces acting in the opposite direction. So let's see what's the actual definition. Okay, I'm gonna show you. Wait. So here you see two equal opposite forces acting along the same line forms a couple. Okay, now see the distance D. This distance is couple arm. Remember that. Okay, don't forget that is couple arm. See, I've written it. C equals to F into D. This is moment of couple. All right, don't tell C by something else. Nonetheless, F into D. Okay. F here remains either of the forces, okay, and D here means the couple arm, as I said you, okay. So they see the determining effect of the force produced by the couple is called the moment of couple. Important indeed. So two types of couple we have, the clockwise and the anti-clockwise. Now the thing is that when you are taking clockwise, you're gonna give negative sign. Conventionally it's that, and when you're gonna write anti-clockwise, you're gonna write positive sign in front of that, okay, because these are vector units, so obviously signs need to be mentioned. Got? Okay, let's move forward. Now see, here it said that moment of couple is either of the forces in the perpendicular distance between the two forces, okay. So you're gonna see body's mass is denoted by M, and F1 and F2 on either of the sides equal opposite parallel forces acting in the opposite direction, acting along the same line of force. Okay, so the thing is that the formula is more important. Okay, so one more numerical here I have for you all. Once again, pause the video and start solving. As you start solving, please note down in your copy this numerical. It's of good importance, and mark your options accordingly, and then you can verify with my answer which I'm going to give. Okay, So let's solve it. I have already solved it. Here you see moment of couple is force into displacement of the force. Okay, so 21 into F into 0.63. Okay, as it's provided here, you need to keep in mind that it's 63 centimeter converted into SI unit, which is meter. That is 0.63 meters. Here you will get only and only then you will get the answer is 33.3, approximately 33.34 newtons. Here it's they have taken the approximation. Okay, so the solution is provided to you, and now yeah, answer is D. Congratulations to all those of you who got it correct. Right, this question, yeah, it's a very good question to say. Two forces of equal magnitude of 10 Newton act in the vertically upward and downward respectively on either side. So determine the resultant moment of force. See, at end A, it's gonna produce an clockwise turn. Okay, see, it's gonna make a clockwise turn. Similarly, over here in the B end, it's gonna provide an anti-clockwise turn. Wait, 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 wait. Yeah, okay. My screen was getting a little hazy, so that's the thing. Okay, so here this one is also going to produce a clockwise, and even this one is gonna produce also a clockwise. So both is absolutely clockwise. So let's see a solution. Moment of force by B at point O. These statements are important. Okay, that is 10 into 2. That's 10 Newton into 2 meters. Similarly, at the end B, you would write the same. So then you're gonna write total is 20 Newton meter plus 20 Newton meter, which is 40 Newton meter. That is ultimately clockwise. So that's gonna be your final answer. Okay. So I think option C is the right one. Got it? Oh yeah. You're gonna be feeling, oh yeah, I did it. So now, buddies, we're gonna get back to our topic, which is equilibrium. Okay, so what happens in equilibrium is that in equilibrium, when a number of forces acting on the body either produce the state of motion in it for a stationary body or to keep on the body moving when it's moving, to keep it in the motion of equilibrium, that is the stability, may it be in rest or in case of motion, that is known as state of equilibrium. What is the first word that comes in your mind when you hear of equilibrium? Mind, it comes the word. Let me write the word. Balance. Got it? Balance. See this tricks. You have this, no? The Guinness Book of World Records and all that. They try to showcase their excessive talents by this. Even in circuses earlier, it used to show that a small girl or a boy is walking down the rope. So this is they're maintaining the balance. They're in the state of balance, equilibrium. Okay. So as I said you in the earlier example that we're considering two equal and opposite forces which is acting on the box. Okay, A and B. Each of them of 10 Newton towards the object. Okay, towards it. So ultimately, the net force which is going to act on the body is 0. So what happens is that box is in equilibrium. It will not move to either of this side. Okay. Easy. Easy peasy. Lemon squeezy. Let's go forward. When a number of forces acting on the body produces no change in the state of rest or in the state of motion, the body is said to be in equilibrium. Note this definition. Types of equilibrium: either in the state of static or in case of dynamic. See, C is missing, okay? I had to put it down, okay? So here you can see I gave you the same example. See, this is the cartoon full of snacks which you X and your sister Y or your closest friend who is a foodie as like me is gonna snatch in either of the side. Ultimately the ropes are gonna tear and they're gonna get back the ropes and the food is gonna be taken away from them. Keeping all that in mind, let's go forward. Yeah. So here we see when an aeroplane flies over the clouds, what we see actually, there's all the types of forces are acting from all the sides to produce that in equilibrium. Weight is acting downwards due to gravity, lift due to air atmosphere, that's gonna apply a lift, thrust which the plane intends to go forward, and a drag which it's stressed backward. Now when a body remains in the state of rest under the influence of several forces acting on the body is in static equilibrium. Keep that in mind. When a body remains in the state of motion under the influence of several forces, the body is in dynamic equilibrium. Understood? If my earnest request would be, if you all feel any doubt, feel free to comment down in the comment section, okay? And even if I make any mistake, no, please mind me, okay? Because I'm so new to this type of taking sessions, so please don't mind, okay? Okay, let's go forward. Now, what are the conditions of equilibrium? Conditions of equilibrium, these are the two conditions for the equilibrium. Let me change the color. This is number 1, which is resultant of all the forces acting on the body should be 0, and number 2, which is nothing but the algebraic sum of moments of all the forces acting about the body about that point of rotation should be 0. Correct? Yeah. Next, coming to the important topic of principle of moments. What is principle of moments? Principle of moment, it states that when two bodies of certain masses, see, one body of a small girl and one of an elder girl, when I'm taking for suppose I'm taking one girl of little mass and another girl of more mass, okay, and then I'm applying seesaw to them, okay. In this seesaw they're gonna do the experiment, okay. In one side I'm putting the small massed girl and one side I'm putting the larger massed girl, okay. Supposedly it's not mass, it's weight, sorry. Now the distance is r1 and r2. So we know that in equilibrium the anti-clockwise moment is gonna be equal to the clockwise moment, as we're gonna see in when the resultant force was 0, equal forces dissipate each other to produce ultimately 0. So here happens the same. The thing is that work done and r1, which is the distance r1, becomes equal to w2 r2. Very important. Okay, let's move forward with the slides. Then we're gonna see, you see, if they are at unequal distances, one would fall one side, they are not in equilibrium, they are no more in equilibrium, as in this slide you can see. Now, what is according to the principle of moments in the equilibrium? The sum of the anti-clockwise moments is equal to the sum of clockwise moments, as I said you previously, okay. So with that, we're gonna solve a numerical, very easy numerical. As always, get your clock run within the track of 1 or 2 minutes, then solve and mark your answers. Okay, pause the video and Do let me know what are your doubts in solving. Now see, two unlike forces of 10 Newton and 25 Newton are acting at a distance of 25 centimeter from each other. Find the point which it will balance. See, I drew the diagram 12 minus x and x. One is 25 Newton, one is 10 Newton, okay? And the distance is 12 centimeter. So what happens is that moment of force on either side should be equal. So here it's showing the anti-clockwise moment, which is 10 into 12 minus x equals to 25x, which is the clockwise sum of clockwise. Okay, so ultimately calculating all those we would get as 30 Newton. So what you would write here, what do you need to write here? You need to write by the principle of moments of couple producing equilibrium, or you can write simply in equilibrium state. Okay, keep that in mind. This is the perfect solution. You just see the solution and you would understand everything. Exactly, option B is the right answer. Let's go forward. What is center of gravity? Center of gravity is nothing but the center of a body in which the whole mass constituted by the body can be considered to be a zero, or the whole mass is gonna act as weight on that particular point in the body. Think of our human body, the point where you can balance your body by putting just a pin, sharp pin on the ground would be your center of gravity. Naturally, you think of a biscuit when you're balancing by pricking it to the center by a small pin. How is that happening? Because it's placed at the center of gravity. Ultimately, sum of the moments, algebraic sum of moments of all the forces acting about the body, may it be clockwise or anti-clockwise, is becoming zero. Okay, that's the logic behind this. Let's go forward. So what happens is that Earth attracts every particle towards its center, which is called the gravity. That becomes the weight of the particle, surely. What happens is the center of gravity weight is always going to act downwards to the center, as I drew. Now the center point is called the center of gravity of the earth. Okay, and center of gravity is related to the gravitational force and the weight of the object. Okay, surely, thus the center of gravity at the point which the torque from the mass of the elements of the object sum to be zero. Understood? Which I said a few seconds ago, the definition of the center of gravity. Okay, let's go forward. As I said, you position of the center of mass of the collection is given by the sum of clockwise moments about the body of the center of the mass is equal to the anti-clockwise moments of the center of mass. Okay, now center of mass of symmetric objects. Symmetric objects, it's given a chart in your book. For this chart is also given in your book, so please do learn, make yourself learn this. For all the symmetric objects, center of gravity this is at the center. So what about the irregular objects, sir? Surely you're gonna nail the center of the irregular lamina and pluck it by a string, and then you're gonna take a chalk to nail down at the line which stretches down from the rope. Okay, then you're gonna change the side and position, as you can see in the second one, and you're gonna do the same. Like this you would obtain several lines, and the point of intersection of that line would make the center of gravity here. Okay, fine. So, mark this sentence. Okay, let me also read the sentence. Incorrect statement is a body can be balanced at its center of gravity. Total weight of the body acts at the center of gravity. The algebraic sum of moments of weight of all the particles constituting of the body is zero about the center of gravity, and the center of gravity doesn't depend on how it is produced. Which one do you think? D, no? Yeah, I also think that's the correct answer. Surely that's the D option. Congratulations to all those of you who got it right. Let's understand one more new topic, which is uniform circular motion. Uniform circular motion is nothing but a body which is in a circular motion with uniform speed. Anything. That's the definition. Let's go forward. Consider a body moving in a circular track with constant speed. That's the uniform circular motion, right? So what happens is here is that the distance covered remains the same, but the displacement is not the same because direction is changing now. In circular motion, we know what? Direction changes at every instant, which is tangential. That's why we define no. Velocity is defined as change of displacement upon time. So velocity is not constant, it's variable velocity, and we know what acceleration is change in velocity upon time. So here is change in velocity, so this is acceleration. And we also know that wait a second, in I'm going back to the question. Wait, centripetal and centrifugal forces, see this, when the body is accelerated there is always a force acting on according to the Newton's second law of motion. This is the centripetal force which is acting on the body. Understand this concept? Okay, fine. Let's go forward. Centripetal force is the center seeking force. Object remains in the circular motion because of its centripetal force. Okay. Now, what about the centrifugal force? Centrifugal force doesn't exist as such in nature. It's just the reluctant, which is the resultant opposite forces which acts in order to judge or to verify the centripetal force. There exists another force which is of equal magnitude but opposite in direction. We cannot call it a reaction force because you know what? Newton's third law, it states that force, every action has got an equal and opposite reaction. In its conclusion, it states that action and reaction cannot happen in the same body. So this same body, no action and reaction gonna happen. So what's that centrifugal? It's just the apparent force that is felt by the object moving in a curved path that is acts outwards away from the path of center of rotation. Okay, very good, nice. Now we're gonna go back to that question which I said you that is important. You already saw the answer, doesn't mind. The velocity of a particle moving in a uniform circular motion at any point is directed what? Along the tangent drawn towards the center, radially outwards, and the plane perpendicular to the circular path. What do you think? Surely? Tell me the answer. Surely, the answer is going to be along the tangent drawn to that point. Okay, fine. Let's go forward now to the last question of our session. So what is this? A stone is tied at one end of the thread which is whirled in a horizontal name. And the forces which provides the centripetal force. Forces on the tension on the string, radial forces on the thread, forces of the stone on the thread, and the force exerted by the end of the thread. Surely option A, force on the tension on the string, right? So guys, I'm very new to this type of learning sessions, so if you like my sessions, please do subscribe the channel, support the efforts. We're gonna work day and night to put you content like this, and if we had made any mistake, please do I'm feeling sorry for it, and please tell us how can we improve the content, and please like the session if in case you got to learn new things, and share it with your friends so that everybody can get the information. And guys, please subscribe to the channel. Okay, so meet you then in the next session. Until then, take care. Goodbye. This is Nijam Rizvi signing off for the session. Stay healthy, stay care for yourself. Goodbye. Peace.